So my name is Sheng. I'm from Rancher Labs, which probably you heard of because of our making container orchestration platform. In fact, now we call this Kubernetes management platform. So we also have another project called Longhorn, which we have been developing for quite some time. And I have presented Longhorn 2 years back at 2017 SDC. A lot of things happened in these 2 years. And probably most significantly is the rising of the Kubernetes. So 2 years later, let's take a look how Longhorn shapes with the Kubernetes and how we deal with the new challenge and adapts. 2 years ago, in 2017, Longhorn is still a project built on top of Docker Swarm, if you are old enough to remember what Docker Swarm is. And at the time, Longhorn was have very basic functions like capable of fault detection and the replica rebuild, and doing some snapshot backup, and we have UI. So in the past few years, as I said, with the rise of Kubernetes and the Docker basically give up on the cluster level thing and turn to the Kubernetes as well. So everybody pivoted. So now we call Longhorn open source distributed block storage software for Kubernetes. And you can take a look at the details here in this github.com/Longhorn. We're very lucky to have that handle. And now Longhorn supports to add persistent storage support to any Kubernetes clusters by just one line of kubectl command. Of course, you can install Longhorn with Helm chart, or you prefer, when you're running Rancher, you can use Rancher to install Longhorn apps. So what does it mean that this Longhorn is for Kubernetes? In fact, before we're talking about how Longhorn adapts into the Kubernetes, we want to show you how Longhorn have currently. This is our latest feature list, and we just announced the Longhorn 0.61 about 5 days back. And we designed it to be an enterprise-grade distributed block storage software for Kubernetes, and we have snapshot, backup, restore, kind of standard thing. And if you don't know about the difference between the snapshot and backup, it's basically snapshot was done inside the cluster. And what we mean by backup, we're backing up your snapshot into outside cluster like S3. So that's we refer to the place you're going to have the backup. We call it as the backup store. And of course, you can restore from backup store. So even your cluster everything is down, you can still restore your volume because your volume is outside cluster. And the latest release, we support storage tag for the node and disk selection. In fact, it's coming from some user recommendation because they have a different disk on the node. Some of the SSD, some of them are probably HDD with spinning disk, and some are probably NVMe. They want Longhorn to have certain capability to select some of them, but not others. Like I want some fast storage for my database, but I want some slow storage for my photos, which I'm going to access every day. So that is we take users' feedback at this feature in the last release. And Longhorn also supports cross-cluster disaster recovery volume with defined RTO and RPO. RTO is a recovery time object, and RPO is a recovery point object. It basically defines that how fast you can get your backup volume up in another cluster. I will talk about more in the demo later. And we support live upgrade, and without impacting the running volumes most of the time, 90% of the time. But when we have, of course, you know that sometimes you have architecture change, you have API change, sometimes well broke. So it's not 100% of the time. And of course, we have intuitive UI, which is the main reason many users like Longhorn in the first place. And once click installation, and of course, we have more features like QoS, volume resizing coming. So this is how Longhorn looks now. How Longhorn works. So this is, in fact, I have gone through this slide before in the last conference, but just want to revisit it, just give you some background, like what's the basic mechanism behind Longhorn. So whenever a Kubernetes create a pod, and the pod asking for a volume, And that's where Longhorn controllers we are going to create 2 replicas, which ideally will reside in 2 different nodes on different disks. And so then we create a Longhorn engine connects to the 2 replica to form a Longhorn volume. And the Longhorn engine will be residing on the same node as the pod, which is the consumer of the volume, and then expose the volume as a block device to the node. The Kubernetes, of course, will take that and format it as like a ext4 file system and bind on the node, and in the end, bind it inside the pod to use that volume. So that's why we call it the volume as microservice, because as you see that the engine and the replica object here is separate processes. They're just microservices that's supporting this Longhorn volume. So if we have more pods, the thing is in fact very simple. We just create more engines and replicas, and everything just become exactly same as what I said before, because you can see the one advantage of this approach is each volume's data path, in fact, is not interacting with each other. They're all separated. So one volume is down, one replica is down, even one controller is down. It's not going to affect any other volumes. It's pretty simple approach. But it's pretty powerful. So that is behind the design idea of Longhorn. We don't want to overcomplicate things. We want to have some reliable, simple solutions to the storage. But of course, the questions will rise. So you have this bunch of engines and replicas, this microservices, this process supposed to be running and support the Longhorn volume. How do you manage all those? So that's coming with the Kubernetes. So this is 2 parts in the Longhorn architecture. One part we call it the engine, which is also we call the data plane, which is how the data flows. Another part is the Longhorn manager, which orchestrates all this the microservices and make sure that every replica in the engine is supposed to be the place it should be. So the manager is looking like this. Suppose you have a Kubernetes cluster, and the cluster issue a request to create a volume for one pod. And that request is going through talk to the Longhorn CSI plugin using the CSI API. The container storage interface, which is called CSI, is a newly development, which the standard format of the how storage connects to we call the cloud native infrastructure, like Kubernetes and Mesos, Docker, they all adapt this. So then Longhorn CSI plugin will talk Longhorn API to the Longhorn manager, which orchestrates all the volumes. And what Longhorn manager do is they talk to the Kubernetes API server. Why? Because the Longhorn manager doesn't have this own data store. Every state data of the Longhorn in fact, it just stored as a CRD called Customer Resource Definition, which is the kind of API extension of the Kubernetes, and we store that data in the form of CRD inside the Kubernetes API server. So you don't need to have a separate plan for how to recover the stateful data for the Longhorn, because as long as you take care of your SCD of your Kubernetes, we're all good. So when Longhorn managers see a request of creating volumes coming, and they will create a volume object inside the Kubernetes API server. And there's a bunch of other controllers running inside the Longhorn manager, which is going to monitor what changed in that Kubernetes API server. And once those controllers see that, okay, there's a new volume object that has been created, but I haven't seen anyone in my local disk yet, I need to create it. Then they were going to create this bunch of engine and replicas and to create this volume, and then in the end, supply it to the pod. So if you have more volumes, we just create more volume objects, and the Longhorn manager, the controller inside Longhorn manager, will create more engine and replicas and to satisfy the demand. Another way to access to the Longhorn manager is through the Longhorn UI. And the Longhorn UI is also talking the Longhorn API, of course. And the difference between goes through the CSI path into the Longhorn Manager or goes through the UI path is because the Kubernetes provide the powerful semantic to create, delete volume, and do some minimal maintenance, like the snapshotter is in the alpha stage and all this. But that is not the full functionality of Longhorn. So Longhorn UI supplements the Longhorn CSI plugin and to provide the full functionality that's backup, restore, and cross-class recovery, and then no tag, volume, all this kind of old functionality was exposed in the Longhorn UI. So I mentioned that Longhorn Manager has a bunch of controller running. In fact, the controller, this word, has special meaning inside the Kubernetes word. There's something called controller pattern or operator pattern you probably heard of. That is what I mean by the controller inside Longhorn Manager. So how does that work? That in fact is the one of key elements of which we can keep Longhorn Manager as simple as possible because we adapt the Kubernetes controller pattern all over the place. So the basic idea of Kubernetes controller pattern is you have a spec and you have a status. The spec, The spec, as I said that, okay, they have volume object, of course it's simplified. You're saying that it's define what is your design state. Say the volume object, okay, I want 3 replicas. Means that my volume has 3 copies, I need 2 of them down, I'm still fine. And the status is what I observed as what's current state, like in this case, I have 3 replicas healthy, so number here is 3. So what the controller pattern is really simple. It's basically just reconcile the status into the spec. Anything is different, say, from what I want to find a path to make the status into the spec, into what I want. So normally we also call this spec as something like a desired state, and the status called the state or status. So you can also see that they have engine, we have engine object, follow the same pattern. The engine object and the spec, we say we have a replica 1, 2, 3 listed here. And the status, we see, okay, we have 1, 2, 3, 3 replicas, and all of them green. Everything seems healthy. But what if something happened? Unfortunately, due to some reason we don't really know, we lost 1 node. As engine, because we data plane is running, we constantly monitoring all the connections, immediately notice that, and they will observe that the replica 3 is red, it's in arrow state, so they change the status into arrow. And you can see the red and the replica 3. And then the volume controller observe that as well, because, okay, so I should have 3 my currently healthy replicas has been dropped to 2, because I only have healthy replica 1 and 2. But my desired number of replica is 3. So I need to do reconciliation. I want to move somehow to make my current healthy replica to 3. Then what engine will do now is say, this is in fact what volume controller did. You see that replica 3 is bad in the engine, so I remove it. So volume controller remove the replica 3 from the replica list inside the engine spec. And of course, engine will disconnect to replica from replica 3. And we also need then volume controller. We're going to create replica 4 on a new node because we lost connection to the node 3, and we probably cannot really reach it at the time. So the new replica was created, and the new replica was added inside the engine spec. So engine controller will see, okay, I have a new replica I didn't really haven't observed yet. So I need to add this to my internal to my state. So the engine controller add replica 4 into this replica list, and the replica 4 will start rebuilding automatically. And by rebuilding, it means just, in fact, in the Longhorn, rebuilding is you just copy the data from the existing replica, healthy replica, to the new replica, and make sure that when the rebuilding is complete, the new replica, we're going to have the same content of the existing replicas, and then we call everything is good, which happens now. So now you can see that this reconciliation logic will just make sure that, okay, I now have 3 replicas, which is all healthy. And I see that, the volume controller see that the currently healthy replicas is back to 3, which is match our desired number of replicas. Everything is good. Nothing needs to be done now until the instance happens next time, or what else.
Question?
Yes?
Will that happen immediately, or is there some timeout to absorb the transient?
So it normally happens immediately because it depends that if engine, how long it takes for the engine to detect this replica is down. As soon as this replica was detected as down, which is supposed to happen within 1 second or probably less than that, and the state of this, the state of the engine replica will going to change to the red, and then this change will going to trigger the response of volume controller. So inside we have this volume controller we call the monitoring this engine object. So any change in this engine object, volume controller, we are going to take a look and decide if there's anything I should do. So as soon as this replica was be changed to the red, and volume controller will go through the reconciliation loop first, figure out what am I right now. So okay, found that, okay, I'm gonna have 2 healthy replicas. Then volume controller decide to take action and starting the rebuilding and converging everything back to the healthy state.
So then if replica 3 comes back a minute later?
Okay, that's a different thing. Okay, because that thing is to deal with the engine itself. If the replica comes back a minute later, because the connection is from the engine to the replica didn't reach to the engine. So the single point of truth, say which replica is healthy right now, is inside engine. Engine already decided to remove the bad replica from the spec, so engine internal state doesn't track that replica anymore. Manager knows about this. Manager knows, okay, something's bad here. We can move it later or repair it later. But the engine already removed that from its internal state. All right, any other questions? Okay. Okay, so let's take a look at what the latest Longhorn looks like. Unfortunately, I was told this network here wasn't very good, so I prepared a video. Where's this? Yes.
Oh, 1 second. Is there audio to the video?
No.
Okay.
Won't be that lazy. Wait, in fact, how to make this full screen? Oh.
Push the green button on the top of the screen. The 3 little green buttons on the left, top left, push the green one.
This one?
No.
Oh, this one. Oh, okay. Okay. All right. Oh, sorry. That's way too quick. So what you see right now is the UI for the rancher. This resolution is a little bit horrible. Okay, so you can see that we have 3 clusters here. I have demo, demo 2, demo, and the dev. These are 3 Kubernetes clusters we just created, and there's just nothing else on that. And this is just standard machines we provision it from like DigitalOcean and Linode, which don't have any specific hardware or anything attached to it. So what I'm going to do now is I'm going to select the demo cluster, and I go directly to the app deployment, which because Rancher has something called apps, which is essentially the Helm chart built by Rancher, and we ship the product with it. You also have your own app directory. And we have the branches official app directory, including Longhorn, and you can just start installing here. And no configuration needed, and click launch. So what you're seeing right now is Longhorn is launching, and you guys see that each component in this app is changing to the green, and everything is going fine. And this Longhorn driver deployer takes a little bit of time because, well, I will talk about that later. It's a little bit complicated introduced by the Kubernetes. And you can see that what's the event and what status of the current this part. Everything looks nice in the UI, but probably too small to see in the screen. All right, so now you can see that this one is all green, and the Longhorn system has been installed. And we can take a look and see Longhorn UI. So click the link inside that app. You go to the Longhorn UI. On the left side, you see that there's no volume. It's supposed to be, so if you have any volume, they will show up here and what their status is. If they're healthy, it's degraded. In the middle is how many storage you have right now can be used to provision in your Longhorn volumes. And right side is how many nodes right now and if they are all healthy. Yeah, and also you can select whatever state and filter it in the volume view. And down here we have an event log showing which is we in fact sent the Longhorn event into the Kubernetes event log, which make it convenient. And here is the node page. We're showing that what's each node, what's the status, and how many storage we can use for provisioning here. It's a real-time data which reflects that due to your real-time usage. And this is how many spaces you can use to allocate. Because we have a default over-provisioning, you can see that, if you can see that the space is probably about 150 G, but you can allocate about 500 G of the volume there. And when Longhorn installed, by default, it will create a default disk using under this path, like while lib branch Longhorn. So this is how, when you just install Longhorn without any parameter, how Longhorn gets the storage. And this is the page on how to configuration node. You can add more disk, you can add a node tag, disk tag, and you can see that what's the real-time status of the disk. And we have no volume right now, and also no backup. And let's set up backup store. So this one point to S3. And after backup store was set it up, and now we can talk to the S3 and talk to backup store and see that, okay, there's already some volume existing there. And you will use this feature later. And now I'm going to demo to start a WordPress app, which also using the Ranch app catalog with the Longhorn volume. So you need to put some password here and select, if you didn't see the option, this one is persistent volume enabled. You need to select it to true. And by the way, this is derived from the Helm chart itself. And the storage class, Longhorn is installed with your Longhorn system. And also we select true for the MariaDB on the persistent volume. Now WordPress is starting, saying, looking to what is happening now. And you can see here is Longhorn connect to the Kubernetes. So when WordPress starting, it's starting the Longhorn volumes and make the persistent volume attached to the pod. So you can see that the volumes has been created, and for the WordPress, you can see that it has been attached to that field. So this is volume detail page. On the left side, you see everything about this volume. On the right side, you can see that this volume has 3 replicas all running, and they are on a different node, which is 1, 2, and 3. So that is the anti-infinity rule for how you place your storage. And what directory, what's a disk, in fact, they're using for storing this data. And we have also snapshot list, and we can also schedule snapshot and backup, just like you want to back up every morning at 1 a.m. That's been taken care of. And in fact, that feature is implemented using the Kubernetes cron job. And the MariaDB is starting. And now we can take a look and see what's the log of the MariaDB. Everything, this kind of feature is built in the Rancher, give you the control of your full Kubernetes cluster. Now this is listed as the event, and the MariaDB is now the readiness check passed. And WordPress was waiting for the MariaDB to start. Now WordPress starting. Yes. WordPress detect the MySQL server, MariaDB, and should be starting very soon. Okay, so now the WordPress has been completely installed, and let's go check the WordPress page. So this WordPress is running on the persistent volume provided by the Longhorn. How can we know that? Let's log in and write something and see if we can somehow recover it. So this just go to post and add new post. At SDC 2019. The post created and some published. All right. So here in the Longhorn UI, you can see what's the name of the volume created by the Kubernetes for the pod, and what's the namespace, what's the workload this PVC was in, and what's the workload this volume was attached to, which is WordPress. The WordPress is namespace, and WordPress is, I think, is the pod name inside that application. And the second one, you can see that is WordPress and MariaDB, which is the name inside the application. So in this page, in this volume detail page, you can take snapshot and create backups. And also, let's just try to schedule a recurring backup at every minute. And we want to keep the last 3. Okay, you can see that this schedule, the light was lit, say that this volume has something recurring backing up, which means that the data probably be safe if anything happens. So that is recommended. We do the same thing for the other volume. We back it up every minute. Yeah, it's not a real case scenario, but for demo purpose.
What was the difference between the snapshot and the backup?
The snapshot was made inside the volume, and so inside that cluster. So if you lost cluster, your snapshot will be gone with it. But the backup is we're backing it up to the S3 or NFS, right? That is outside your cluster. Now in this case, we're backing up to the S3. So As I mentioned before, we have a disaster recovery volume in case that your whole cluster, original cluster, goes down. You can quickly recover your workload and spin everything up in the new cluster. I'm going to demo that right now. So that uses our backup and restore technology. This is, if you didn't notice, this is the Longhorn system in the demo 2 environment, in the demo 2 cluster. And they have nothing on that. But we are using the same backup store, so when you click the backup, you can see that this new backup was created about 1 minute ago, which in fact is from our original cluster. And when you click the name of that volume, you will see how many backups have been there made for this volume. And you can also see, okay. On the right hand, there's a label. If you click that, you will see that what workload it belongs to. We're going to use that later. Okay, now you see that 2 new backup has been created, and the last backup is both 2 seconds ago. That is coming from our original cluster. So you can see this, because the Kubernetes always only use this random UID for the PVC, it's very hard for you to tell who is who. But if you click the label here, we have stored original workload information by default here. So you can easily identify that which volume is supposed to go with which part and applications. And then we create a disaster recovery volume. And you can see this one is attaching it automatically and start to restoring whatever the latest backup on the backup store. And we are going to create another one. So these are 2 original volumes, and I'm going to write something in this WordPress and make sure that when I reactive my disaster recovery volumes, those contents will be there. All right, so then we'll wait for that newly modified content to be synced off in the backup. Wait a few moments. In fact, at that place, let's speed it up, because you probably need to wait 2 minutes to get the contents in. Okay, so this is the new cluster, which is supposed to be the backup, which is supposed to be the backup cluster for the original cluster. And now it seems fine, and some disaster happens right now, and all the original cluster is down. Now I need to use these DR volumes. So I activate the disaster recovery volume. And after activate, this volume will be detached, because for the block device, for the read-write once device, Kubernetes can only mount it on the one node. So you cannot have the volume attached and try to use Kubernetes workload with it unless they happen to land on the same node. So here, because we record the original workload information, so I can simply just use the previous PVC and make Longhorn just create the PVC and the PV for this volume. It makes life much easier rather than just remember what the name is, because if you know, and in the case of a stateful set, the name must be identical to the original one. You cannot use a new PVC with new name. So one PVC was created, PVPVC was created for the WordPress, another one was created for the database. And now let's try to start the WordPress on the new cluster and see if everything is there. The demo2 cluster, default namespace, go to apps, launch, try to find WordPress, and the same version, use the same password, enable persistent volume, use Longhorn storage class, and select WordPress PVC. And you see that if I choose to use MariaDB persistent volume, it doesn't even give you a place to choose which PVC you are going to use, because that's all embedded, encoded by what your name of application and what the name of your volume is. So now those two volumes we just restored is starting, and they are attaching to the corresponding workload like WordPress and MariaDB. The WordPress still in the starting process. Okay, this is the MariaDB started, should be running soon. And the WordPress is waiting for MariaDB before it started. Yeah, I think WordPress, yeah, now the WordPress started too. So still, just using the link in this app, and you can go to the WordPress, and you can see that the latest commit is disaster recovery volume demo, which is from what is inside, what's the latest on the original cluster. Yes. So that concludes my demo. Yeah, before I go back to the slide, do you have any questions? All right. So Kubernetes, in fact, serves multiple roles in the Longhorn. First of Kubernetes is container orchestrator. That's how we deploy Longhorn components inside the Kubernetes cluster, like a Longhorn manager, serving as a demo set in the cluster, and we have drivers, CSI attachers, and Longhorn images. All these components were deployed by the Kubernetes. And Kubernetes also gives us some update about what the status of that node. Is the node down? Is the node have been pressured? And we can deal accordingly in the Longhorn side. And of course, for the status monitoring, so somehow one Longhorn manager is down, Kubernetes will restart it automatically. And of course, everything they connect to is Kubernetes API server, which is single point of truth. And also, there's one scenario which is interesting, because Kubernetes, when one node restart, Kubernetes will restart the workload. Of course, Kubernetes will restart the workload and that node, but Kubernetes never asks the storage vendor to reattach the volume on that node. They kind of assume that it's already attached. We found a way to automatically reattach the volume after node reboot in that case. In fact, it's just with some help with Kubernetes, one field of Kubernetes node status. And the Kubernetes also serves as application framework for Longhorn, because the controller pattern. Kubernetes serves as the data store to the manager. The manager state are stored in the Kubernetes API server and etcd. And Longhorn uses CRDs and controller patterns to reduce complexity. We don't have very complex state transition machine, state machine. And by reduce complexity, we also increase resiliency. And because we can always make sure that there's a way, if we can find, towards the final desired state. And of course, we build Longhorn for Kubernetes, and the Kubernetes acts as user of Longhorn. It's kind of easy to plug in. You can use either CSI or Flex Volume Driver. The Flex Volume Driver was officially GA'd, but in the Kubernetes itself, the community normally refer you to, you should use CSI when you start development. And when you install Longhorn, we'll come with install the default storage class for you. So you can provision the PVC using Longhorn automatically. And any Kubernetes workload was supported through these interfaces. And in the future, we're going to support snapshotter, a row-block device, and a volume clone. This kind of features provided by the Kubernetes interface. There's also a few challenges. In fact, the reason I mentioned that we have a driver deployer is because the driver interface of Kubernetes keeps changing. It's basically the default in the Kubernetes 1.10 is different from 1.11, and the one works on the 1.11 doesn't work on the 1.12. So the Flex Volume was originally the standard, and then deprecated and changed to the CSI. And the CSI, each version before the 0.0 doesn't compatible with the version before. So we built that driver deployer to detect that what environment the user was in, which version of Kubernetes he used, does he have enabled a certain feature to try to automatically deploy the correct answer, the correct driver for the user. That is in fact was one of the side effects by the fast-moving Kubernetes development. You have to pay some price somewhere. Another challenge is, in fact, the state for workload and Kubernetes. It's not really works as good as people would normally think. If you are using RWO volume, which is basically means read-write once, which is basically the block device, you can not self-heal if the node is down. Because when you're familiar with Kubernetes deployment, you say, okay, I want three replicas for this pod. One pod is down, I will spin another one. Kubernetes will do that for you. But in the case of stateful set, Kubernetes will do nothing if that node is down. You have to manually delete that node, delete that pod or that node for Kubernetes to attempt to respin that pod. But also, when you probably ask that, okay, we can use deployment, but the limitation of deployment is no matter how many replicas you have, your deployment only going to have one copy of each volume. So for example, you have 10 replicas, you want to assign a block device to it as the persistent volume. All these 10 of replica will go try to share this one volume, which is not possible because you are, of course, can use this 10 replicas across different nodes. Block device is not really shareable. So that is some problem right now with the Kubernetes stateful workload. There's some approach on upstream Kubernetes using tent and using some timeout mechanism try to remedy this, and we'll still see how it goes. So for Longhorn, the next step is we're going to announce 0.7 release probably 1 or 2 months from now, and they will be our first beta release. Oh, I have talked so much about Longhorn, but it's still in alpha. And we're going to add volume resizing, performance metrics, and the quality of service support to it. We're really looking forward to Longhorn, the first beta release, and we have been working on this for so long. And it will be really nice if you can see the beta and the GA very soon. And the GA will be in a few months. All right, that's all for my slides. Any questions? Yeah.
So what happens when a disk dies?
Because when disk dies, in fact, it's just equivalent to the replica die because we cannot write to that disk, right? And then the controller will detect that this replica is somehow unresponsive. The controller will disconnect that replica. And as I mentioned, that the controller pattern, the reconciliation logic will kick in and start the replica on someone else and copy the data from the healthy replicas.
So in that case, a replica is always tied to one single disk.
Yes, replica is always tied to one single disk. At least in the current design, we're thinking about probably splitting them up. We're using striping, but it seems too complicated now. And also, we also depends on that the modern fast storage normally have very high capacity, and we haven't have a user say this problem yet, but we do but we'll see.
But if you have a lot of drives in that node, do you take advantage of all those drives?
Yes, you can. As I mentioned, as I showed before, on the node configuration, you can add multiple disks to it.
And it's concatenated, or is it how do you manage them? Separate drives, or is it concatenation?
No, that's if you don't run something like LVM on top of it, each drive is considered its own. It's just one disk, and we're going to have one replica have to fit into one disk.
So okay, so the merge then you use LVM.
Yes. Okay. Yeah.
What do you use for the replication?
We copy the data ourselves. We wrote some software, just copy the data from one replica to another replica.
So it's out of band, asynchronous?
It's asynchronous, yeah. Oh, okay, so there are two parts. One is what I'm saying that the data was copied from one replica to another replica. This is happening on the rebuild step. And when you write the data, that data is writing in a synchronized way. We're waiting for all the replica to say, I got this data before we continue. That is a synchronized process. Yeah?
I'm not sure if the comparison is appropriate, but if you compare root plus set with Longhorn, what's the difference?
Okay, so the one problem about Ceph is really inspired Longhorn. It's way too complicated. You have to understand that the crash mapping, you need to know that, okay, so I don't configure this host or this configuration wrong, so I didn't put two copies of the same volume inside the same disk. We saw I'm previous with the cloud.com and the Citrix, we're doing cloud infrastructure things. We saw some customers happens to configure Ceph wrong, and then one disk dies, the data lost. So that is one complexity of the Ceph, which is we think we probably can improve. Another thing is Ceph doesn't really have built-in snapshot and backup mechanism. So everything, they assume that every data in your cluster is supposed to be safe, but what if a cluster is out? Of course, there's a third-party solution for that, but there's no built-in solution for the backup restoring in the Ceph itself. Yeah?
So so these are seen as block devices within each.
Yeah.
How are those mounted?
You mean how this block device was implemented?
Yeah.
Yeah. So in fact, that's a pretty interesting story. We have looked into all kinds of solutions. The first one we use is NIO, which is very unstable. It's not usable. Another one we take a look at is we try to fuse. And we try to fuse, like, we write a file, and we use the L mount around putting the looped by device and that's way too slow. And later, we found something called TCMU. TCM is another name for the LIO, which is the Linux in kernel SCSI target. The TCMU is the part that you can use a user space process and talk to the interface, to, of course, this control interface, and you can expose a block device on the kernel side. So we used that for a while, and in fact, I contributed some patches to improve the speed of TCMU, but we later realized that it takes about 2 years for that patch from I committed in the upstream and the user can use it. This is way too long. So we put TCMU on hold, and we trying to find other solution. In the end, now we're using TGT. We wrote a backend for TGT, connect to the Longhorn controller, and the TGT serves as iSCSI target, and we utilize the iSCSI initiator on the host to connect to that iSCSI target to expose the block device. So far it's pretty stable. Yeah, okay.
So why did you use LIO? I'm sorry, why did you use LIO?
Yeah, because okay, you can use LIO, but that's introduce a dependency on the kernel.
Okay, got it.
Yeah. And in fact, we're also looking at some other options like SPDK, see if that can help. So far, the performance is acceptable, so we'll try to improve on the function and the CPU utilization part. All right. So, okay, I think that's it. Thank you.